Hi guys, today we are going to be going over the last part of forces that you guys need to know, or the last of the forces that you guys need to know for your matric year of technical sciences, and one of those is tension. So by definition, tension is a force acting on a string or a rope. Now there's a couple of examples of this, and I'm going to show you the various examples as we speak, right? So an example of tension would be if we have a block of mass 5 kilograms, let's say for instance, and that block is being held up by a string, and that string is connected to a wall. A force occurs within the string, and that force is known as the force of tension. Another force on this block that's acting downwards would be the force of gravity, and you guys can clearly see that the force of tension is stopping the block from falling down, so it's the opposite force to the gravity in this circumstance. Another example of there being a force of tension, if we have two blocks and they are connected by a string, and that string is being pulled by an applied force, so that's F applied. In the string or within the string we have a force of tension occurring. So basically, tension is a force acting on a string or a rope, and it's important that that string is inextensible. It cannot stretch in any way, shape or form. Let's move on to an example. So an example here would be a mass of 5 kilograms, and here we do not have a diagram. I always like to draw my own diagram to see what's happening, and you guys, it's always beneficial for you guys to learn how to model certain things from words. So a mass of 5 kilograms is hanging by a light inextensible string from the ceiling of a roof. So there's my roof, here's my 5 kilogram weight. Calculate the tension found within the rope. Well, in this case, to find the tension, it's not direct. What I can say is that in this case, tension acts similar to a normal force. And what do I mean by that? Well, we have a 5 kilogram block, and without this rope, it would not be connected to the wall. Without this rope, it would fall down, right? But what is causing it to fall down? The force of gravity is causing it to fall down. So you guys can clearly see that the force of gravity is acting downwards, and the force of tension is acting upwards. So we can say that the force of tension in this circumstance is equal to the force of gravity. Why is that the case? Well, the force of tension is acting upwards, and the block is not moving upwards. The force of gravity is acting downwards, and the block is not moving downwards. So we can conclude that the force of tension is equal to the force of gravity. But what is the force of gravity? Well, we know that the force of gravity, otherwise known as weight, is equal to mass multiplied by gravity. So we can then therefore conclude that the force of tension is equal to mass multiplied by gravity as well. Well, what is the mass of this block? 5 kilograms. And what is the gravitational acceleration constant? We all know it's 9.8 meters per second squared. We multiply those two together and we get an answer of 49 newtons. Let's move on. So another one of the things that you guys need to know about forces is that sometimes forces have components, namely a horizontal component and a vertical component. Now, when does this occur? I'm going to show you guys an example. Let's look again at an object or a block of mass 5 kilograms. And that block of mass is being carried with an applied force, but in this case, the applied force has an angle, right? So we have F applied over there, and that angle is 20 degrees. Well, if we look at the applied force, we can clearly see that this applied force is a vector, and that vector consists of components itself. Why do I say that? Because this value has a value within the horizontal axis, and it has a value within the vertical axis. Now, what are components? Let's look deeper. This vertical piece of this vector is known as the vertical component. And this horizontal piece that makes up this vector over here is known as the horizontal component. And in a lot of circumstances, we need to use this if applied with this vector over here to find the vertical component in certain circumstances and the horizontal component. And how is that done? It's a rule of thumb that the horizontal component, also known as Fx, is equal to the force itself, and in this case it's F applied, but we're just going to say force, multiplied by the cos, a trig value or trig ratio, apologies, multiplied by the angle itself, and that angle is represented by theta. To find the vertical component, so Fy is also known as the vertical component, we are going to say Fy is equal to the force itself multiplied by sine multiplied by theta, or the sine of a specific angle, and that angle over there is represented by theta. Let's jump into a quick example. Calculate the vertical and horizontal components of a 20 Newton force that acts on a 10 kilogram block at an angle of 35 degrees. Well, again, we are going to have to represent this. We're going to have to visualize what's happening. Let's go and visualize what's happening. So there's our block, and that block is 10 kilograms. And they tell me that we have a 20 Newton force acting at an angle of 35 degrees. So there's my 20 Newton force, and I'm going to call that my F applied. And this 20 Newton force acts at an angle to the horizontal of 35 degrees. Can you guys see that? And they want us to calculate the vertical and horizontal components. Remember that the horizontal component, to find, we are going to go with the formula f of x is equal to f multiplied by cos of theta. Well, what is the force itself? Well, the force itself is 20 newtons. So we're going to replace the f with 20 newtons. Then we're going to go cos, and we are going to replace the theta. We are going to replace that theta with the angle. And what is that angle? In this case, the angle is 35 degrees. And then we are going to go for the answer. And that is 16,38 newtons. What about the vertical component? So if y is equal to f sine of theta, and both of these formulas, guys, are given to you within your paper. Right, so f sine theta, and that's going to be 20 newtons multiplied by the sine, in this case sine, and then the angle. And what is that angle? 35 degrees. Right, and let's get the answer quickly. And that answer is 11,47 newtons. So what we basically did over here is we took this specific angled force or angled vector, and we broke it down into a horizontal component as well as a vertical component. And again, let me just emphasize that the horizontal component is the piece that goes horizontally like that over there. So that component over there of this force is the Fx, and the Fy is the vertical component, that vertical component over there of this specific force. And that is the end of all forces that you guys need to know. Within the next lesson, we're going to be covering force diagrams, free body diagrams, and all the diagrams you need to know how to draw within the exams for the year of 2024 matric.